All right, hey everybody. This is more of sentential derivations. We're now going to talk about something more theoretical rather than practical about how to do these proofs. And so this should be a pretty short video, but I just wanted to explain something about our system of derivation we've now developed. So we're on slideshow 16, page 46. What I wanted to point out now is that the system of derivation that we have, that is our rules that define how to do show lines, so conditional derivation and direct derivation, together with our rules of inference, that is those 8 rules on the left-hand side, is a system that logicians say is both sound and complete. And let me explain what that means. To say that a system of derivation is sound means the following. It means that if some formula C is derivable from some premises P1 through Pn, then the argument that has those premises and conclusion C really is valid. That is, if you can derive a conclusion from some premises, then were you to do a truth table of that argument, you'd find out that the argument's really valid. Obviously, soundness is something we want. We don't want to be able to derive things that are not themselves really valid arguments. What's completeness? Completeness tells us the opposite in some sense. It says that if an argument, if we have an argument of the form P1, P2, dot, 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 up to Pn, so it's got n premises, and conclusion C, if that argument really is valid, then there is a derivation of C from those premises. So together, soundness and completeness tell us that what we can derive matches up perfectly with what we can show using truth tables. And that's a really strong result. It's really, really sort of powerful result, something that's maybe somewhat surprising, but also something that's really necessary. Soundness is important because it tells us that we'll never go wrong with the system. That is, it tells us that if we derive something, then it really is valid. So we're not going to be misled by our system. Obviously, soundness is important. But completeness is important too. You can think of completeness as sort of telling us that we won't be wasting our time. That is, if we've got an argument that really is valid, then there is a derivation. We're not going to be sort of searching in vain for how to complete the derivation. Once we know the argument's valid, we know that there is a way to derive it using our rules. So, in a more simplified way, here's how you can think of it. Soundness says, if derivable, then valid. That is, if an argument's derivable, then it's valid. Or equivalently to that, if it's invalid, then it's not derivable. And completeness tells us that if it's valid, then it's derivable. Equivalent to that, if it's not derivable, then it must be invalid. Now, if our system has these properties, and it does, it's sound and complete, you might wonder why it isn't guaranteed to tell us if an argument is invalid. That is, we can't use our system to definitively establish invalidity, although we can use it to establish validity. And you might think, well, look, couldn't we use the completeness of our system to establish invalidity in this way? Completeness says if it's valid, then it's derivable, which means if it's not derivable, then the argument's invalid. So couldn't we look and see, hey, if we can't derive an argument, doesn't that show us for certain that it must be invalid? And the reason why that thought is wrong is because it's really difficult to know if an argument's really not derivable in principle, or if you just merely haven't been able to figure out what the derivation is. And so for this reason, even though our system is sound and complete, we can't use it to establish invalidity with certainty. We can use it to establish validity because once you have a derivation, you know it's definitely valid. But because we don't know when we lack a derivation, we can't say for certain if an argument's invalid. Just a little note here before we conclude. To say that a logical system, a system of derivation of the sort we've been developing, is sound, is very different than saying that an argument is sound. And it's sort of a shame that the same word is used here. An argument is sound when it's valid and all of its premises are true. So soundness for arguments is a property of arguments, premises, and conclusion. A proof system or a derivation system is sound when it's true that if you can derive a conclusion from the premises, then the argument really is valid. These are just very different sorts of concepts. Again, we just happen to use the same word for them. Here's an analogy. River banks and financial banks have nothing to do with each other, even though they're both referred to with the word bank. Same thing for soundness. Arguments are said to be sound, derivation systems are said to be sound, and those concepts really have very little to do with each other. So just make sure you don't get confused. So our textbook doesn't show us how to prove that our derivation system is sound and complete. I've just sort of told you that it is, and you just have to take my word for it here. But it is actually something you can prove. And proving something about a logical system, if we were to do such a proof, takes us into a field that's called metalogic. That is, you're proving things about your logical system. So it's above your logical system. It's a meta-logical proof. If you're interested in that kind of thing, it's usually covered in more advanced logic classes, and I urge you to keep an eye out for advanced logic when it's next offered. All right, that's all there is to say about soundness and completeness. In the next video, we're going to add to our system. That is, even though our system currently is sound and complete, we can add a few things, a few extra rules, and one more proof technique, one more derivation technique that, even though not strictly necessary, as we can see from soundness and completeness, will nevertheless make our proofs, our derivations, a lot easier to complete. So that will be the next several videos.